So welcome to my talk. I want to discuss how to write test logic for your build scripts and also for your plugins, custom tasks, and so on. And more specifically, we actually want to focus on the functional aspect of testing. So how do I write tests from the end user's perspective so we can see how it behaves in real life, as if we would basically run our build script from the command line. In this talk, we want to answer questions like, why is it even important to write tests? I mean, valid question, I guess. We could manually just run the build and see if it works. We want to talk about the different types of tests that we can run and write and execute. For example, unit tests, integration tests, functional tests. Why should we have a good mix of these tests? Also for build logic. And then we actually want to get to the meat of the presentation where we talk about Testkit, which is the functional testing support that we have in Gradle core for testing build scripts from the end user's perspective. And I will show you a bunch of demos, and we'll look into the features by example. Just a couple of words about myself. My name is Ben. Some people probably already know me. I've been working for Gradle for roughly, I think, 3 years now. And last year, we've been implementing Testkit, which was a good exercise, simply because many people already wrote similar logic, and we wanted to make it available as a Gradle core feature. So what do we usually see in client projects? So we see more and more clients moving on towards continuous delivery, continuous deployment. And as part of that move, they usually put together a delivery pipeline that automates pretty much everything along the way. Compiling the code, building your artifacts, testing, of course, is a big deal, and deployment to production. So that's certainly usually handled by such a deployment pipeline. And of course, you need to write some automation code to drive that logic, that process. Hopefully, many people do that with Gradle. But we oftentimes have a good mix of scripting languages and other build tools or other tools that we might know from the ecosystems. So it's usually a good mix. So usually, we're happy if we can ship the code fast and frequently to the client. That's the main purpose of continuous delivery, that we can push out new releases on demand by just pushing a button. But what happens if there's anything failing in that process? Well, we write build logic, so there could potentially be bugs that we haven't uncovered. And imagine that you changed a plugin in that process, which now has a bug. We didn't try it out before, we didn't exercise it. And all of a sudden, this is happening as we want to ship new features, new bug fixes to the client. And that basically leaves you stranded with a failed deployment. So potentially you have to roll back, have to do things that you don't want to do necessarily at a failed deployment. And you can see the other ship there on the horizon. That's pretty much your competitor. Apparently, they are doing it right. And they apparently do not manually just test their build logic. They seem to be doing something different or have better tools, apparently. So, crazy idea. Why don't we just test the build logic as well? We know that as a practice in software engineering, we do that for application code. We write unit tests, integration tests, functional tests. So why can we not apply the same practice to build logic as well? And if we look back at the tools that we've been using in the past, it becomes kind of obvious. So people that have been using Ant, Maven for a long time might know there was not the right tooling for it. There was no real test harness that we could use to actually run the build and inspect kind of like the outcome of the build in any kind of form. And that makes sense. This is actually changing now with Gradle. We have support for functional testing in Gradle core called Testkit. And I think that's pretty powerful. The community actually reacted to that a while ago, multiple years ago actually, and they started to write their own plugins. One of them is Nebula Test. Many of you guys probably know it. So it basically uses the tooling API under the covers to drive your build and then inspect kind of like the outcome of the build. And we realized, well, actually, it's pretty important for plugin developers. We should actually support that in Gradle core itself as an API or some sort of toolkit. So before we actually get into the gory details of Testkit itself, let's talk about how we can write different types of tests in Gradle. And we want to identify typical use cases here for unit testing, integration testing, functional testing, and we'll also see one example for Testkit as well. So one important aspect about testing is that we definitely want to test your build logic on multiple levels. And the lowest level really is kind of like a class level. We want to be able to test a specific class, which might be part of, let's say, the build source directory or a plugin, and want to test that in isolation. Doesn't usually touch the Gradle API. Could be some Pojo utility class. Still, we want to make the class testable. And we can easily do so by writing a general purpose test that we would write for application code as well. For example, with JUnit, TestNG, Spock, what have you, whatever you feel comfortable with. The important part here is that it actually doesn't touch the Gradle API. So let's have a look at one example here. And I picked this example from one of my plugins. It's called the Gradle Docker plugin. So it lets you manage and maintain Docker images in containers. And what I have here is that I wrote a class which is called from instruction. And that's just a plain class. It simply builds a representation of a from instruction for a Docker file. So nothing too crazy. And what we want to do here is to see if we pass in certain parameters, and that could be a string or a closure in this case, if it builds the correct output. And we can see here in this specific test, there's no import of a Gradle API in any kind of form. So we could choose to use Spock, which I did in this case. Pretty handy because it has this nice where statement where we can iterate over different test cases here and run the same logic and make the assertions. So I think that's pretty simple. I would highly encourage you to write any kind of like testing logic that you can do for plain classes, Pojos, and so on. Of course, most of the times it's slightly more complex. There's the Gradle API that you use in maybe a custom task or a plugin, of course. You have imports. And usually that main entry point for these classes is a project instance. So maybe you have some build logic that creates new tasks. And we usually create tasks with the task method or the task container, up to you. But of course, we need to have some sort of like almost real-life project instance. And that's why I usually call it a integration test that integrates with other components. In this case, the Gradle API, but could also be other things. You make calls to HTTP servers, what have you, database calls, as we would usually do in application code as well. And usually in these cases, we don't execute a full build as is. So we don't have a build.gradle file which simply sits somewhere. We just want to build up some logic that we want to use for testing the code that we have in place to basically emulate what we're building with a plugin or with something else. So let's have a look at an example. So I think this becomes more clear then. What we have in this case here is that we want to apply specific plugins that I also provide with the jar file of my Gradle Docker plugin. I apply the Docker Java application plugin. And we want to make sure that the interaction between the application plugin, which comes with Gradle core, produces the tasks that I actually want to create with my plugin. So in this case, the assertion would be, if I apply this plugin, please create certain tasks. If they are not there, then something is wrong with my plugin. And you might ask yourself, if you're not super familiar with kind of like the Gradle API, how do I produce that project instance? How can I actually apply plugins? Wouldn't I have to have some sort of build script? You actually don't have to have a build script. We can use a class which is called ProjectBuilder. It's one of the APIs that we provide in Gradle core. And with that ProjectBuilder, you basically have to point it to a specific project directory. It basically just acts as a placeholder project directory where you can create new files. For example, imagine you're compiling code. It would end up in your build directory, of course, your project directory. And then we produce that instance of the project with the build method. That's pretty much all you need to do to create such a project instance in the context of an integration test. Keep in mind the project instance that we are creating here almost acts like a real-life kind of like project, not quite. There are some gotchas. where you have to call specific hooks and lifecycle methods to make it act as if it would be a real-life project. But if you wanted to a build script to really act like as it would act when you run it with a build script, then we would basically go towards a functional test. So in this case, we basically would stand up a build.gradle file. We want to see how it behaves at runtime when we provide certain tasks, certain command line options, and we want to see if it produces the output, the outcome, certain tasks being run, and so on. So the important part is about functional testing is that we don't want to let certain user space settings bleed into our testing setup. So what do I mean by that? By user settings, I usually mean Gradle.properties file, which sit in your Gradle user home directory. So imagine you set up parallel builds and stuff like that. You don't want to necessarily run your test code with the same settings. If you do want to apply these settings, then you can still do that, but as part of the setup for your functional test. So they're usually separated. So let's have a look at one example here that already uses the Testkit API. And as I mentioned before, we need to have a build file, build.gradle file. So imagine build file actually points to the file which already exists. And what we do here is that we create a task of a specific type. And that task is provided by my plugin again. And we provide a certain method calls here, a from statement, a maintainer. And based on that definition, we basically create a Docker file when we run the task. So nothing too crazy. So how do we actually run a Gradle build with Testkit? And we do that with the main entry point, with the main class that we usually interact with, which is called Gradle Runner. So once you create such a Gradle Runner instance, we can feed it with the project directory. That's the place where we have the build.gradle file. And then we provide the arguments that we want to use for running that build. That could be tasks or a list of tasks. It could be command line options that we already know, -I for info level, logging, and things like that. So that actually doesn't change, so you don't have to relearn certain command line options here. So you can simply use the same ones. And then once we created that, yep, one question?
Does it take a list of strings?
Yeah, so there are actually two different methods. Either you can provide a list or an array, or var args, basically. So it's pretty convenient. You don't necessarily have to create a new list first and then pass it in. It's actually slightly more convenient. Once we run the build method here, we get back a build result. So basically what happens under the covers is that we run the build. And the build result is basically the return type of our execution, which provides us with information about what tasks have been run and what was their outcome. And when I talk about the outcome, I usually mean, was it successful, did it fail, was it up to date, skipped, and things like that. And also, did the build produce any output on the console? Either a system error or a system output. We capture both. And then you can basically make assumptions based on that build result. On top of that, we can, of course, test whether whatever the task does internally actually is being produced. So in this case, we actually say, well, when I run this task, it should actually create the Docker file. I mean, that's the main purpose of my task here. So that's kind of like a first taste. What is Gradle Testkit in a nutshell? So it's basically functional testing support in Gradle core. One important aspect about Gradle Runner or Testkit in general is that it's not bound to any specific testing framework. I might show here a lot of examples that are based on Spock, on the Spock framework, but if you want to run the same test with JUnit, you can. We've seen that Gradle Runner is just basically a class that you import into your test class, and then you create a new instance and basically run your build. So it's completely agnostic of the testing framework, which is kind of convenient. So we don't necessarily have to stand up specific setups for different testing frameworks. It simply works as you basically use it in your test classes. And one important aspect is that we basically use the tooling API under the covers. You might have used the tooling API in the IDE. You might not know that you did, but many of the tooling providers actually use the tooling API to bootstrap a Gradle build. One thing that's kind of important is that when you run a build through the tooling API, then you basically execute the build in the Gradle daemon, as we usually know that. And that's not different for Testkit either. So we use the tooling API as the actual test execution harness, send basically the information, whatever we want to run, to the Gradle daemon. It will be reused if it already exists, and we get back the result from the daemon to the actual process that starts the actual test. Gradle Testkit can be used with any Gradle version greater than 2.6. So I think by now most of you guys are probably, hopefully, already on 2.6. If you are not yet, then I would highly encourage you to upgrade. Makes a lot of sense, just in terms of performance. So what can you do to actually use it in your own project? What needs to be set up? Actually, just two things. Pretty simple. We introduced a new method on the dependency handler domain object, which is called Gradle Testkit. And that basically assigns a dependency on the Gradle runner API in these classes that we'll discuss in this talk. And you've seen there, I simply use the default test compile configuration. You could use any other configuration that is bound to a test source set. Could be a custom one, so it's really not, again, specific to Testkit. And then, of course, you need to define some sort of testing framework that you want to use for writing your tests. That could be Spock, which it is in this case, but it also could be JUnit, again, something else, TestNG. So let's have a look at a slightly more complex example, and I want to show you how this looks like in practice. So what we have here, let's have a look at the code first. So basically, I have a build script, which I want to test now. So I simply want to run a build script which already exists and might be part of a separate project in your organization, and you want to see if it actually works if I run that build. How it looks like at the moment, it applies the base plugin to get some basic configuration in place, and then we basically just create a task of a specific type. The type simply looks at a directory, or actually a file tree, and looks for specific text files. Once it finds these text files, it simply sums up the sizes of them. So nothing too crazy. And we can also see that we have a logging message here, which we also want to assert if it actually happens when we run the test. Okay, so that was the script on the test that we want to test. And as part of our build setup that actually runs the test, we want to say, well, we want to use Gradle Testkit in this case, we want to use Spock, and we want to write our test with Groovy, of course, because in this case we have Spock. You might wonder why we actually need the system property that we pass into the test task. This has been used because we want to tell Testkit, or the Gradle runner instance that we are about to create, where that script actually sits. So the project directory, which I've shown to you guys before, with project here, that method call, needs to be set in some sort of way, and by default we cannot derive that, so I'm simply passing it in here. Okay, and then we write a Spock test again. We simply extend from specification. We read the system property, which is called project here. And then we simply set up a new test case, which says if I run the build, then I would expect a certain outcome. And that outcome is that the output on the console should contain our logging message. Pretty simple stuff. Generating text file. The task that we are running should be successful. Hopefully it is. And then the actual text size file is being generated, and it has, potentially we could even assert that it has the proper size, which I don't actually do right now. So let's give it a shot. For now, I want to uncomment this one call, forward output. So don't think about it right now. So what we want to do here is that we want to clean it first and then run the task. So nothing too crazy would happen. We compile the test code first, then we run the test with the right class path. It has Testkit and so on. Was successful. We only ran a single test. Let's have a look at the actual test report. Okay. And you can see here we run our functional test, and it ran our test case. Pretty cool stuff. Simple use case here. So far, we haven't actually seen any output from that build. So by default, Testkit only captures the output from the console, but it actually doesn't render it. Doesn't put it into the report. If you wanted to switch that over, maybe for debugging purposes and things like that, then you can still enable that with forward output. So let's give that a shot as well. Quickly run it. Okay. And let's open this guy. And we can see now we have some standard output. So this is usually what would have been created from the command line. And we can see that in our build report as well. So I usually try to chop that off. If my build produces too much logging, then I usually don't want to see it. I just want to know that I actually captured it, and I can make my assumptions based on that. But if you still wanted to see it, you can. So you might ask yourself, when do I actually want to test a build script, just a plain build script? Usually that's the case for migration strategies. So imagine you and your organization, you're using Gradle 2.10, but now we want to upgrade to 2.14. And want to ensure that all your builds that you have in your organization are compatible. Do they use deprecated methods? Do they break and things like that? So that's kind of nice to ask the Gradle builds and simply to run them with a newer version of Gradle and inspect if it actually works before you upgrade or before you roll out a version on the enterprise level. And for that purpose, we would have to pass in a specific Gradle version. By default, when I run Gradle Testkit with the Gradle command, it will simply use the same version as I've been using so far that is installed on my machine. So we can pass in these versions, and we can even pass in a list of versions and then run the test case with each of them. So I think cross-version compatibility testing certainly is very useful if you wanted to, if you're going for migration strategies, or if you wanted to figure out, well, the plugin that I wrote is compatible with 2.5, but is it also compatible with the latest version of Gradle, or even with older ones? Like some of your users might tell you, well, it doesn't work with 2.3, and then you can actually look at it, write tests for it, and I think that's pretty powerful. I actually see this feature in the long run in the plugin portal as well. Let's see if we can actually make it happen. I would love to have this in there, that you have some sort of compatibility testing out of the box. You submit your plugin, and then the plugin portal automatically tells your users it is compatible with the range of Gradle versions that we tested with. So you might ask yourself, where do these Gradle versions come from? And that's not different than using the Gradle wrapper. When we use the Gradle wrapper, we by default ask the public server that we have in place. And we would download the specific version if it's available. We can also point it to a specific URI. So if you host your own Gradle distributions in your network, then you can point it towards it. Or if you already have a Gradle version that is installed on your machine, why not use that one? So it pretty much depends on what you want to use here. And again, there are multiple methods that we can use on the Gradle Runner API. If we just wanted to retrieve the Gradle distribution with a specific version from the public servers that we host, you can simply use the method called with Gradle version, provide the string. Then we can point it to an installation on your local disk. And also, if you host it somewhere internally on your network, you provide an URI. So I think that's pretty simple stuff. There's actually not more to be done. And keep in mind that the version that we use to run the build here and the version that we use to execute the test are actually different if you pass in a different version. That's something that you have to keep in mind. So let's try that out as a demo. And before we actually run it, let's have a look at it. So the actual script under test didn't change. And also the build script didn't change. The only thing that we actually wanted to change is the method call that determines the Gradle version. So down here now, we actually provide a specific Gradle version. And we simply call that method with Gradle version here. And we use that where clause from Spock, pretty powerful, which simply lets you run the same test case with multiple values. In this case, the value is basically the Gradle version. And we want to test the build with 2.8, 2.9, and 2.10. So once we run this guy, we should now see 3 tests being executed, 1 for each of the versions, of course. Let me clear that. And run Gradle clean test again. And instead of seeing 1 test being executed, hopefully we see 3. Keep in mind that if you don't have the Gradle distribution on your machine yet, Gradle will be happy to download it, of course. Let's also have a look at the generated report. And now that we look at it, kind of convenient, we also provided the version string to the name of the method. So we see exactly what has been executed with what version. And of course, also standard output now executed the build 3 times. Okay, so I think that was a fairly simple setup for testing build scripts in general, but we want to enable you to also test your plugins, of course, so usually there's more to it. Testing plugins requires some additional setup, and we'll have a look at that setup in a minute. Keep in mind that we run the tooling API, and again, we send the information over to the Gradle daemon, so the actual execution of the Gradle build and the test that we actually execute run in different JVMs, and we send information back and forth. That's something that we have to keep in the back of our minds. So if we work on a plugin, usually we are dealing with binary plugins most of the times, and actually work on them as separate classes which need to be compiled, which also means we have to tell the Gradle daemon somehow now, where's this class coming from? So we have to add it to the class path. We have to send it over to the daemon process now. Simply because it has a different class loader, or multiple class loaders actually, than the test process. So let's have a look at how this plays out in practice. And you will see, and you will agree with me, that it actually requires some boilerplate code. So instead of just having the plain setup, I hope you can read that, but I will talk about it, is that we now also have to produce a task, which is called create class path manifest. This guy basically derives the runtime class path from the main source set. These are basically our plugin classes that we are compiling. And what we do with those is that we write them to a text file, line by line. Also external libraries that we potentially need from the plugin, things like that. And what we then do is that we pass it on as a file collection to the test runtime configuration. So we want to make it available to our test classes so we can read them. All right? Let's have a look at the actual test class. You can see here, hopefully you can still read that. So basically what we do here, we ask the current class loader for that file. We now have it on the class path because we provided it with the test runtime configuration. We read again line by line, keep the class path, and then basically just pass it in through the build script configuration to make it available on the class path for that build script under test. So now we actually have the plugin classes in the class path of the build script that we want to test. So that sounds kind of complex, right?
So you're writing it to a file and pass it into the test kit.
Yeah, exactly. So in the test, we actually read that file again, and then we pass it in through this statement.
It's just because it's on a different configuration, it doesn't know about it, right?
Yeah, it wouldn't know anything about it simply because it's a completely separate process, JVM process. Okay, so let's give this a shot. Still want to show you that this actually works. Gradle clean test, and in fact, hopefully this still works. The output should look fairly similar to what we've seen before. Just want to see if it was successful. All right, looks like that was the case. We can see we can apply the plugin, and I actually changed the code. I actually didn't show you the code of the plugin itself. I changed the code slightly. So this plugin just applies the base plugin and creates a task at runtime that simply creates text files and writes to them. So nothing super crazy, but what we asserted here is that, that the task that we got from the plugin was run successfully, and it created the text files that it should produce with that task. All right.
Is that documented anywhere?
Yeah, so that's documented in the user guide. And I think we can both agree it's kind of complex, right? There's a lot of boilerplate code. Isn't there an easier way to do this? There is, in fact, with one of the latest Gradle versions, I think 2.13 added functionality similar to that under the covers with a plugin. You could imagine if you work on, let's say, 10 plugins, you would have to copy-paste the same code over and over again, kind of very clunky. So you can actually apply the same logic with the so-called plugin development plugin. Does anybody know what the plugin development plugin is? Are you actually using it? Yes? Okay, all right. So the plugin development plugin is not so well known, actually. But in the long run, what it's supposed to do is that we support plugin developers and make it easier for you to actually implement your own plugins. There are certain things that are already built into it. For example, before you publish, we evaluate the metadata and things like that, and we want to enhance it over time. Of course, if you deal with plugins, you have to have the Gradle API dependency on the class path, so we already do that under the covers. And with Gradle 2.13, we now also hook into the Testkit. So what we do here is that we automatically apply the Gradle Testkit dependency. And all the logic that you've seen before in the previous example would be created under the covers. So you don't have to set up a task anymore that produces it and all these kind of things. It's being handled automatically by the plugin. One important thing here is that if you wanted to inject that class path automatically, you have to tell Gradle about it. Or more specifically, you have to call a method on the Gradle runner API. Just to indicate, yes, I want to use that guy, we want to use the class path which has been created under the covers for us. And we do so by using the plugin DSL as well. So let's have a look at an example. Oh, before I do that, let me quickly show you what needs to be done on the configuration side. So we apply the plugin. The name of the plugin is the Java Gradle plugin. And then what you need to tell the Gradle runner instance is that you want to use the plugin class path that has been automatically generated for you with plugin class path. That's the method call that you have to definitely call. Otherwise, it wouldn't simply use that plugin class path. Yep.
When you use this new construct, do you use it on older versions of Gradle like 2.8, 2.7, or no?
Great question. And I will actually get to that in a later slide, but let me already talk about it. Keep in mind that certain functionality has been added as we develop Testkit, and under the covers that also require changes in the tooling API. So that kind of means that we can only use certain functionality in Testkit if we use specific versions of the tooling API, which are basically the same. So certain features are simply not available with older version of Gradle versions. So it depends on what you want to use. There's actually a compatibility matrix on the user guide which tells you exactly the feature and the minimum Gradle version that you would need to use to actually allow you to use it. So you can basically look it up. We actually wrote a whole test suite around that to ensure that we actually verify that.
Is there a Groovy plugin as well, or do you just use Java?
So what you would do if you wanted to use the Java Gradle plugin, you use the same plugin, but simply on top of that, you apply the Groovy plugin. Everything else works out of the box.
Apply the Java plugin and just apply Groovy.
Exactly, yep. Okay, let's have a look at that. We want to simplify that logic. Has been bothering us. And you can see it became so much simpler. We simply apply the Java Gradle plugin. We don't even have to say Gradle API anymore, Gradle Testkit, and all these other things. We still have to provide the test framework that we want to use, but everything else is pretty much cleaned up. Let's also have a look at the test case.
They exclude because you got the Spock.
Yeah, we don't want it to conflict with the Groovy version that comes with Gradle itself. You can see here now I did two things. One of the things was that I applied the plugin with the plugin DSL. Keep in mind, this is something that you have to do if you want to use the injected class path. And then you have to call the method with plugin class path. So you could not use the generated class path out of the box if you use just apply plugin and then or Gradle text size. It actually has to be the plugin DSL. That's where we hooked it up with. Okay, so I think we don't necessarily need to run this. It has the same outcome, but the code actually got much simpler. And you might ask yourself, that's great. What are the conventions that the plugin uses? By default, we use the main source set to derive kind of like the plugin class path. So everything should be there. It is configurable, keep that in mind. And then by default, we are injecting it into the test source set that is available with the Java plugin. So these are usually available simply because we apply the Java plugin anyway. All of this is configurable. So imagine you would have a setup where you have a custom source set for functional tests to keep them separate from unit tests. Then you can still configure the Java development plugin, plugin development plugin to use a different source set and inject it into your custom source set. So let's have a look at that and see how this is slightly different. So here again, we apply the Java Gradle plugin, have the same setup. And what I did here is that I moved out the logic for setting up that custom source set into a different script plugin. So let's have a brief look at that. I think it shouldn't look too crazy. So we simply create a new source set for functional tests. So they should actually live somewhere else. So imagine you would have a plugin that not only creates unit tests, integration tests, but also functional tests. We potentially want to keep them separate in separate source directories. And that's what we basically are trying to do here. And the directory in this case for that source set would be source functional test groovy instead of source test groovy. That's the default. So you might ask yourself, how do I switch over to that? And I mentioned the extension before, which is available from the plugin. That extension is called Gradle plugin. And it provides a single method, which is called test source sets. So we can basically assign different source sets that should be used for injecting that plugin class path.
So like if you had integration tests, for instance, you create that, that's where you put it?
Yeah. So if you wanted to inject the plugin class path also to your integration tests, might be a good reason for it, then you can actually add multiple also. So it's basically a list of things that you can pass in. Okay. And you can see here our test lives under functional test now, or Gradle build logic. Everything else doesn't really change. And if we would run that, which I won't do right now, we would get the same results. So basically, set up the tests to actually be always successful, kind of boring. So that's why I'm not going to show it to you. So remember when I said all the builds that we actually execute run in the daemon, because we basically use the tooling API, we send over the information to the daemon process, which makes it kind of hard for debugging purposes. So imagine you live and breathe in your IDE, you basically code in your IDE as well, and you want to debug basically your plugin code as you write tests for it. So how do you step through the code that runs in a different JVM? So we might know what we need to do in regular Java code. Maybe we add some, I don't know, remote debugging parameters and things like that. But that is basically a functionality that is built into the tooling API. Right now, it's an internal method which lets you run the tooling API in what we call the embedded mode. And the embedded mode basically tells Gradle to run basically your test within the test JVM. So it doesn't actually call off to the daemon anymore, which then makes it possible to actually step through your code and things like that. There are two ways to enable that. One way is to do it programmatically, so we could simply add the method with debug, set it to true. And the other way, which I find more convenient actually, because it lets you add it on an ad hoc basis, is that we simply go into a test at the system property, which I'm showing here, and then we enable pretty much that test to run in debug mode, which then would let you step through your plugin code. So let's also have a look at that. So there's nothing different about this specific project. What I added here instead is the idea plugin. So let me go there. So I want to generate the project files first. And I believe I already had them, so I'm just going to clear them out for now. All right, we generated them, which should automatically set up our class path for testing as well. That also means we have the Gradle Testkit jar file on the class path, Gradle API, and things like that. All right, this might take a while. So we bring up the IDE. Maybe IntelliJ might have to index the whole project. It actually does not have to. And you can already see that we have our test case set up here as a run configuration. And we can see that we already set the system properties, so we want to actually be able to debug our plugin code. So if we would run that, then we could automatically step through it. And you can see here in my plugin code, I added a breakpoint in this spot. So let's see what actually happens. So if I run this, we run that specific test case. Internally, it applies the plugin. And as we apply the plugin, of course, certain logic kicks in. For example, the do last action, because we requested it to be executed. And now we can basically, as with any other application code, we can step through it, debug it, see what the values are. So I think that's pretty powerful, especially if you have more complex kind of plugins. And of course, if you're calling off the Gradle APIs, you can attach basically the sources for it, and then directly also jump into the Gradle sources and see what's going on there. So I think that's pretty powerful. Now I'm coming back to the feature limitations. So if we look at the Testkit page in the user guide, Gradle Testkit. You will see there's basically a compatibility matrix we have down here, which tells you exactly what Gradle version you can use with specific features of Testkit. For example, if we wanted to inspect the build output if we run in debug mode, what I just showed to you, then we have to use at least Gradle version 2.9. So the Gradle version is the version that we pass in for testing your build script or your plugin. So it's not necessarily the version of the Gradle runtime that you use to run your build. Could be the same, but if you provide the with Gradle version or the other methods, then it would potentially be a different version. If you basically use a feature that is not supported by the Gradle version, we would throw an exception and tell you, because it doesn't actually make any sense.
If you say run version 2.30 as the Gradle you called it, what's the earliest version of Gradle you test against for compatibility?
That is 1.0.
Okay.
Mm-hmm. All right, so what do we want to do in the hopefully near future? So we want to add additional things to Testkit, of course. There might be additional requests from the community. One thing I could imagine to be added is certain convenience-based classes, for example, for Spock or so, where you don't have to set up like temporary directories anymore and things like that, and already create certain setups. That's something that I could imagine in the near future. Same thing for JUnit, TestNG, and things like that. We also want to hook into the IDE plugins. So all the setup that you saw before could be made more convenient. So if you generate the project files, we could potentially already create a debug run configuration for you out of the box and things like that. And one thing that I actually already got a request for from the community is the support for Jacoco. So once we generate a code coverage for unit and integration tests, we potentially also want to see that for functional tests. And the hurdle here is simply because we, again, run the tests in the Gradle daemon. So we have to hook up the Java agent that Jacoco creates that it uses for the metrics or for determining them to that daemon process. So we want to make this convenient. You can already make it happen in your own build scripts, but again, requires some boilerplate code. So we want to make this much easier. If you wanted to contribute, I put the spec down there. That's where we have the next milestone. So if you wanted to like send us a pull request or join into the discussion, that would be great. So that's pretty much what I wanted to cover in my 45 minutes. I think actually we're on point. So we still have probably a minute or two for questions. If you have any, I can still also stay here for another 10 minutes. Any questions or suggestions?
I think it's nearly my Gradle case plugin redundant for them.
Oh, I'm sorry. No, yeah, it's good for you. You don't have to maintain it anymore. Actually, I think that's what we wanted to get at. I mean, like, we wanted to make it like a first-class kind of citizen in Gradle core. And certainly, if there's anything that you're currently providing, let us know, and we certainly want to build it in. Or if you want to work on it, certainly.
From a functional perspective, you know, as you change parameters, your plugin might accept you get more or less tasks, for instance, you get more fewer options. Would you write like a single class with a certain set of configurations or a certain set of options, and then pretty much hammer everything you would do in that one build? Write another class where you change the configuration option, where you add something else in the closure. You get more tasks or fewer tasks. Kind of hammer that all in one class.
Yeah, so I think if you find any kind of like common logic, you can basically break it down into base classes. For example, apply a new plugin. You don't have to like duplicate it in every test class, but try to make them specific to the functionality that you're about to test. For example, you change a property or you use a DSL to configure your plugin. Could be a test class, and you will see how many test cases you actually have. If it grows, you can still break it up again. So I think try to make it as small as possible, the chunks, and make it maintainable, really. Any more questions? I would say thank you very much.